All right, so that's the permanent magnets. And now let's talk about non-permanent magnets. Also called prods. Prods. So prods are handheld electrodes. Handheld electrodes. So you're going to hold them, put them on, clear, pull the button. You can also cure somebody with arrhythmia. So we have current travels up through the prod, down through here, current travels through here, current travels back up and over, thus the arrows. This is direct or indirect magnetization?
Direct magnetization.
All right, direct magnetization, which is going to produce, would you say circular or longitudinal?
Circular.
Circular, and would the crack indication go this way?
Yes.
Or this way?
Way.
This way.
Yeah, that
Okay, then. So, this is me trying to be silly. So the indication would go this way, and I had this theory, what happened if you wanted to test for an indication going this way? But the problem is, you couldn't test this way because this piece is fixed, and you couldn't change it, and so the part didn't fit between. So I thought, well, what if I put the prods here, and the indication is going this way, right? And I lay this on top. Would it transfer up and make the indication? It didn't work. And the guy's like, what are you doing? I'm just seeing something. So, what's that?
You killed somebody on the table.
It's
The students who don't listen.
Yeah.
Well,
It's just rust.
as the kids these days say, F around and find out. Maybe I did.
What's that?
Figure it out.
Fool around. It's like, what does that stand for?
We can't always
Well, that's fantastic.
Well, that's fantastic. All right. See, currents pass through the part. Through the part. Current is through the part. When we run current through the part, what is my risk?
Arcing.
Yes. So this creates circular magnetization. Discontinuity shows parallel. Current flow. So discontinuity shows parallel to the current flow. Let's see here. As with the yoke, you can use dry powder or wet. So if you use wet, how are you going to get the wet there?
Spray.
Those spray cans. So if you're using spray cans with an aerosol in them, and you have prods that are prone to arcing, and you're inside a closed vessel, or you're doing pipe welds or something, you have the risk of losing your eyebrows.
You don't need those.
We've all done it.
There's only like a 1 in 4 chance they won't grow back.
Limited to about 800 amps. Why do you think it's limited to about 800 amps?
So you can keep your eyebrows.
More or less. Try putting more in that. The more amps you got, the harder you're going to have to lean into it and get a good contact.
Oh, 'cause it
You
wants
start-
to blow off.
You start losing your, I don't know about that, you start losing your contact. So, all right, and we've really kind of gone over all of this already. as we went through each things, but I'll bring it back up again. So I kept, and there is a log in the lab, and I noticed I don't think anybody's been using it. Anybody been using it?
For the,
Have you? You guys start using it?
for the Magnaflex?
Yeah.
Write everything down. Yeah, we've been
Nice.
using it.
Okay. Excellent. So I kept a log in my shop with everything every day. It did not matter what table 1 said to me about. Let's see.
About the intervals.
About the intervals. And let me tell you why it didn't matter. Because number 1, let's see. I made sure that, I guess I pretty much followed this. I did check my black light intensity every day, ambient light every day, visible light every day, system performance using the Ketos ring every day. So I guess I followed that. Wet particle concentration, yep, every single shift. Water break test never did that. Or wet particle contamination, I changed out my stuff, according to my boss, way too often. However, we were only calibrating our machine every year, so there's a problem with that, right?
Yes,
So that would not meet this requirement.
This is out of the ASTM.
ASTM, although I don't believe that the service bulletins we used reference this ASTM. So, process control. All right, so we have to have equipment must be verified as working and capable of detecting the desired flaw. Equipment must be verified as working and capable of detecting the desired flaw. I should say the undesired flaw. What do you suppose happens if you don't do this and your process control sucks and it comes to find out that you've been missing things you should have found?
Then you have
People might
NASA
die.
forms ready.
Okay, of course people might die. Let's say nobody dies or somebody does. Then what happens next? Yeah, they embarrass you pretty well. When you start getting into airworthiness directives, especially of smaller aircraft where smaller shops work on things, you probably won't see this on Boeing or Airbus. But places where, like I said, smaller things happen, you will see a lot of shops mentioned by name in airworthiness directives. Like crankshafts, any crankshaft repaired by Nelson Balancing Services between this date and this date shall be removed from service because they were doing something wrong. And so Larry just mentioned he thinks there's a place in Stockton that just had ADs come out on their prop work. But you'd be surprised how many shops are just named by name. And how long do you suppose that AD is out there? Yep. And it's not like they kind of go away. I mean, they are there. It's like, that's why I remember Nelson Balancing. Why do I know that name? Because I've been looking at that name for 30 some years now. And every time I do an annual on my plane, I go through, nope, that one's NA because my aircraft was not, the engine was not overhauled. The
It's still
crankshaft by
business.
Nelson. I don't think so, no.
Yeah, probably
I
not
wouldn't,
after
no.
that.
So, all right.
Time to change the name of the shop.
So obviously we're going to check the media. All right, so the dry powder or the aerosol is a single use. Even though you see me pick it back up and put it in a jar, it's single use. So that includes aerosol cans.
You don't put the stuff back in the aerosol can?
You can try. It's hard to get in that little hole, but or dry media. Single use. I know you see me reuse it because I'm cheap. We're not. All right, it is assumed to be good. Uh-oh, there's that word.
Oh no.
Assumed to be good if used by expiration date. Now, this is my thing. It will depend upon what the expiration date says. If it says best when used by,
It's not an expiration date.
that's not an expiration date because it goes best, better, good,
Gooder.
questionable, and then I guess feed to kids and see what happens. So my family's so mad at me because I'm always on them. You threw away that. It said best when used by. What comes after best? Like, I know, best, better, good. So, all right, that's the joke. So it will say expires on, and it will have a date on there. And, all right. So soon to be good if used by the expiration date. All right. What about sour cream? When it goes bad, does it get less sour or more sour?
Oh man, that sounds gross.
It starts to look like you made the.
You know what I keep telling my kids and won't buy it? You know what tastes really good is lemon milk. Try it. It's delicious.
No, curdles it.
I did try that.
Oh yeah, toothpaste flavored orange juice, my favorite.
All right, the media in the bath. How often is that checked?
Take a bath.
Yep. Every 8 hours or shift change.
What if the shift never changes?
Then every 8 hours. So to check it, we have a procedure. So we're going to agitate it. Agitate for 30 minutes. And if you don't know what the word agitate means, you can ask Cooper because he manages to agitate me for pretty much 2 hours a night.
You got a break yesterday.
I know, I did. It was boring. So to turn on the pump, let it run. Down there, the pump runs and it agitates it constantly. So we're going to agitate it for 30 minutes. We're going to place a sample. We're going to place, obtain a sample in a 100 milliliter centrifuge. Centrifuge. So there we go. I know. That's our machine too. Yes, guess when I took this one? I came back from COVID. So there's my centrifuge. And what I do is I actually get it flowing out of the tube. Then while it's flowing, bring it over, fill up the tube, and then move it away. So you don't just start it. Because I think with the machine, when you shut it off, because ours is clear, you can see the particles kind of work their way back towards the tank. And now you're left just clear in the tube. Just the carrier. So that's why I want it flowing, and then I take a sample. So we take a sample. Let me see. Oh, that's not what I wanted at all. Sample. And there we go. So 100 milliliters, and we're going to let it set for, oh, I forgot a step. We are supposed to demagnetize that.
You're supposed to demagnetize
The sample.
how do you do that? Oh, I guess you put it in the search.
Put it in a coil. Put it in the heads.
Just take the yolk and just.
I fail to see what's wrong with that.
All right.
Refuse.
Demagnetize. Let stand for 60 minutes. It says minimum. And that's for oil-based, which is what we have. This is kind of a weird thing because, to me, it's like if you let it set overnight, I mean, it really settles, and you get quite a bit more than if you let it set for 1 hour. It's still sort of in the jar, kind of floating around. I like to take it right about 60 minutes, between 60 and 90 minutes, and just that's what it is. I don't want it to set overnight because, believe it or not, these particles settle down in there, and they pack in there so tight that you can't get them out the next day. It's really crazy. I put my thumb over the centrifuge and upside down, I shake it, and those particles just stay. I've taken brake cleaner on a straw and sprayed it in there, nothing. It's like the only way at that point to do it is get like a little tiny rag on a welding rod and shove it in there and stir it up and pull it out.
Just get a
Try a
magnet.
magnet.
Yeah.
I haven't thought of that. Because I could just see it going against the glass. Clink! I have another centrifuge, please.
One of those little tiny ones. And
Centrifuge
for
is single
for the
use.
opening of it.
And it's all stuck to the thing.
Examine under black light and compare color and particles to an unused sample. Yeah, good luck with that. They look the same. And our concentration should be should be 0.1 to 0.4 ml. And that is 0.5 is right there. 0.1 is right there. And this is 0.25 right there. So I like it just a little over the 0.25 after about 60 to 90 minutes.
Very artistic shot.
Well, you like that?
Can you see it?
Yeah. Let's see. Media bath. We got that. Machine operation. How do we check our machine for proper operation?
By using it.
We'll talk about the bench. Bench. What do we test it with? The Ketos ring. How often do we test it? Daily.
Just in case it lost some of the battery and fell out.
There we go. Ketos ring, which I think everybody's had a chance to see it work now, hopefully. So we're going to check it DC at 1400 amps, 2500 and 34. We should 3 indications, 5 and 6. The thing that bugs me about the ASTM is it says to check it on AC. It does not say anything about, I'm sorry, DC does not say anything about checking it on AC. And these are old ASTMs. I had an AC only machine, so I still checked it and would make sure that I had at least 3 or 4 showing at 2000 amps, but technically, in order to follow that ASTM, you'd have to have a DC machine, but then you didn't check the AC function, which just bugs me.
So, what kind of, I'm curious about, what is the cutoff for what you consider to be an actual line on the Ketos ring?
Oh,
Because it starts getting fuzzier and fuzzier.
yeah, but that's what a subsurface indication looks like.
Yeah.
I try to be careful because you do get confirmation bias. You see where the hole is, and then you can look out and go, oh, of course I see it, right? It's like, of course you see this one right here. Let's see. You see that one. I mean, that's, but you know, you wouldn't see that if it was a crankshaft you've been examining for the last 10 minutes. You would just probably pass right over. I don't know. It
You
depends.
see the next one too, even.
Yeah, you can, yeah, it's,
So it's where that cutoff is where I'm kind of curious.
I just say if it's
Yeah,
visible.
I counterintuitive.
You have to understand what would an indication look like that deep down. That's what it would look like. So I count that.
It's kind of a training. It's like training your eyes.
It is very much so. Yeah, I guess I never said that, but it's very much so training them. Oops, let me see. All right, so bench Ketos ring daily. We tested on a bar at 14, 25, 3400 amps, giving 3, 5, 6 indications. The other thing we can use is something with artificial discontinuities. Which is something we could use daily. And these would include a pi field indicator. I have seen some publications that say you use the other side, and I've seen some the battery's just there for scale because we didn't own one, and so I was like, that's how big they are. So somebody didn't think it was like this battle. But now you've seen them since I bought one. Yeah. So the other side, do I have a picture of the other side? Let me see. I do not. So the other side is just the copper piece. So I saw one publication said, well, this side would be more for testing surface discontinuities because it represents the surface. So you have 8 pieces of ferrous metal in between non-ferrous metal, some copper in there. So these indicate cracks right here and will work as cracks. Or as I showed you guys, you could flip it over, which still works for, they're so thin that you can use that for surface discontinuities too. So either which way, it'll show you which way the field is going to go, and it always goes, how many lines you get. You get 1 line, 2 line, 3 lines, and you don't get the 4th. It's almost always the way it is. So we can use the pi indicator, or we can use QQIs. QQI, I'll write it down. Qualitative Quality Indicator. QQI. And what they are, they're little stickers. So I had some somewhere. I just don't know where I put them.
Qualitative quality.
I'll write it down. Yeah, Qualitative Quantity Indicator.
Quantity.
Nope. Qualitative Quality Indicator. So they're just small little metal stickers that you'd peel off, stick it to your part in an area that obviously you can't inspect under, and then when you put it in the magnetic particle testing machine, you are going to get, depending on what you did, if we did a headshot, we would get this line would show up, and if we got a coil shot, it'd be this line, referencing the way I'm standing, and you would get part of the circle, I would assume. So that you would see that these indications would show up on the part as you're inspecting it. I think that's all I have for these. Yep. So artificial pi field indicator and QQI, small metal shims. I don't think shims is a very good word, but that's what, because you're not shimming anything. I'll put stickers. Small metal stickers that are attached to a part. We already talked about the lift test. Lift test for which parts or which things? Yoke, magnets,
and the prods.
prods. And we talked about lighting. So for visible inspections, we need what?
1,000 lux. Or 150.
Minimum of 1,000 lux visible, which is 100 wood candles. What about for fluorescent inspections?
Minimum of 20 lux.
What is my maximum white light?
20 lux.
Maximum white light.
20 lux.
20 lux or
2-foot candles.
2-foot candles. Black light.
Minimum 1,000 microwatts at 70 squared.
Minimum of 1,000 microwatts per centimeter squared at 15 inches. All right. and no cracks or damage to the filter. I have some health issues. Now he tells me about health issues. Let's see. Standard caution with chemicals.
Drink it.
Oh, you remember that question that thing you gave us?
That was liquid pen though.
Oh.
I thought the same thing for one of them. It was like the type of particulate or whatever you use. I was like, oh, that's what. But I was like, I don't know. It was liquid pen.
Black light. Black light can cause eyes to fluoresce. It actually causes the fluid in your eyes to fluoresce. It's only temporary.
So how long would one
Probably.
How
Huh?
long would one have to stare at them instead of black light?
It's instant.
Look at it.
Instantaneous.
Instantaneous?
Yes.
I'll set a timer and you stare for 30 minutes.
I mean,
5
I
minute
still
intervals.
have the haziness go away, but
The achiness, what? The what?
I'm saying the fluorescence, the fogginess still hasn't gone away, but I'm sure it'll be fine. The hat man is coming.
So for that reason, you want to keep the black light below eye level. Like the one I hung up.
Be cognizant of reflection of black light.
Yeah, you probably don't want to wear a white lab coat.
Well, if you have it at a certain angle, it'll bounce off your.
Yep, bounces back up at you.
I just throw
It looks so
glasses
cool.
on and everything's red.
Yeah.
You straight up look like doctors and scientists, and it's like when they walk around with blue white lab coats.
That's what we are.
All right. And then the rest of my notes are going through the procedures, which I had to do before because we didn't have anything. We didn't have a machine to do it with, so we just had to talk about it. So we did good. So let's see.
You guys out the test?
What did we do before? We had a very, very weak one that we could only use the rattle cans on, and I think it only went up to like 500 amps at best it would. And so you'd put in a grossly cracked crankshaft, like, I think I see something. So
They brought in like
Is that
20
why
car
you're always
batteries
so
and just
astounded at how clear some of the indications are?
who what?
Is that why you're so astounded at how so clear some of the indications are?
No, I'm used to them from when I actually had a machine that worked well. And
Very well.
no. This book here is another book that I just checked for that formula, and it actually spells it out much nicer, and it uses the 10 minus t divided by 8 in just that bracket. It's the same thing. Checks out. So good. Let's see. Dry particles are more sensitive for detecting discontinuities beneath the surface and are usually used with portable equipment. I highlighted that.
I agree.
Wet particles. Because wet particles are suspended in a liquid medium, which is much denser and more viscous than air, they move in the leakage fields more slowly than dry particles. So there we have it. For subsurface discontinuities, dry particles are more sensitive. Wet technique is usually best for very fine and shallow discontinuities. What has more sensitivity, a residual or continuous? All right. Which is preferred? When you're doing dry powder, here, the particles should reach the surface of the part as a thin cloud with practically zero velocity.
I kind of wondered, like, with that dragon over, that little penetrant, something like that, but then you clamp the part in, it magnetizes it, and you airy in there, you know?
Yeah, but it can't have force. I mean,
No, so that's the way it's just aerating the powder in the Delta powder bag, if it was that.
I guess, yeah.
Yeah, but then that's now no longer porous. Oh, but you can make a portable version of the bench too.
Yeah, I mean, it's got wheels, isn't it? It's portable. Just comes with it rolls.
See Cooper just like just tie it to the back of the Corolla and
Okay, we need you to MBT this and push that whole magnifying out to the plane.
and it has the covers all around it, and you got Parker in the back. Hey,
Yeah, with us fucking gallon.
5 gallon drum.
we're talking about getting the next
Running and
Corolla,
driving.
strapping it to the Corolla.
All right, ready? It's all right. I was looking at stuff. Questions. A material with a permeability of 500 or greater, and I didn't cover this really, I should maybe, is referred to as a diamagnetic, paramagnetic, ferromagnetic, or non-magnetic.
Ferromagnetic.
Ferromagnetic is correct. It is a magnet. Magnetic lines of force, flux lines flow.
Say it again.
Say it, yeah, say it again.
Magnetic lines of force, or flux lines, flow from north to south within a magnet,
Yes.
follow the path of least resistance, distort and cross one another at the side of a crack, or all of the above.
North to south.
It's all, yeah, it's all the above.
They think about the Earth. You have a magnet in the Earth, and so I said it comes out the top, it falls down,
Yeah.
it goes into the, and goes
South to north.
south to north in the magnet.
Oh.
Yeah.
Easy.
Distort and cross one another. Magnetic lines of flux
No,
never
they cross.
cross. Therefore, they follow the path of. All right. Electromagnets are made from. Electromagnets are made from material with high reluctance, copper and aluminum, material with high permeability, none of the above.
There's high reluctance, high permeability, or what? Copper and aluminum?
Yeah.
Not copper and aluminum.
Material with high permeability. Magnetic lines of force can
Yeah.
permeate it easily.
What is reluctance again? It's
Huh?
what's? What did you say the
You're
first
thinking
one?
of retentivity.
Reluctance, it takes a lot of force to magnetize it. If a bar magnet was bent into a ring and fused together, the magnetic field would maintain inside. Would be contained within the ring is correct. A material which, after being magnetized, still has a strong magnetic field is said to have, let me see, low permeability, high retentivity, A and B, or high permeability.
Oh.
Low permeability, and high retentivity, A and B. A material which the atoms are easily aligned into magnetic domains was said to have low reluctance, high permeability, low retentivity, all the above. All of the above. Low reluctance, that is true. High permeability, that is true. Low retentivity, also
So
true.
low retentivity and low reluctance are the same thing.
Yeah.
Wow.
Not the same thing, but they kind of go hand in hand.
Correlated.
They go in.
Yeah.
Alright. Let me think of the same thing.
No.
Ooh, when the point has been reached where further increase in a magnetizing force, more amps, will not result in an increase in flux density, the part is said to be
Not
saturated.
Yeah.
Surface discontinuities are best detected by using. Rectified three-phase AC, alternating current, direct current, half-wave direct current. Just alternating is correct. When the flux field is parallel to a discontinuity, the indications produced would be sharp and distinct, broad and fuzzy, weak or non-existent, or linear. Weak and non-existent.
Yeah, parallels to the lines of flux.
Yep. Think about circular going this way, and it would show up this way because all the lines of flux are not going to go parallel. So weak and non-existent. Very good. Let's see. Magnetic field created in a part placed inside a current carrying coil is a vector field, circular field, bipolar field, longitudinal field. Longitudinal. Magnetizing a part in a current carrying coil will permit inspection of a part 36 inches long or greater. This is a coil. In a single magnetizing operation. True or false?
False.
Detection of a circumferential type discontinuities.
That's a big word.
Yeah,
Yeah,
it's
it
a big
was.
word, so it's got to be false.
Okay. Detection of both surface and subsurface discontinuities if half-wave DC is used.
That sounds true. Half-wave is good.
Yeah.
We like half-wave.
Okay. So surface and subsurface, we've seen that already with the Ketos ring. It'll, okay, and then, well, it's not quite surface. Yeah, it is. And coil, detect circumferential. Yes, so B and C would be correct. When it is desired to inspect the inside of a surface of a hollow tube, or tubular part, tubular, inside, you must use
Conducting rod.
central conductor technique.
Yeah, you're so smart.
In order to detect a subsurface discontinuity located parallel with the long axis of a ferromagnetic part, it would be necessary to subsurface discontinuity located parallel with the long axis.
Oh, yeah.
Circular magnetism DC.
Magnetize the part by passing current through the part.
Yeah.
Create a circular magnetic field in the part. Use either half-wave DC or full-wave DC,
Yeah.
or all of the above.
All the
Oh,
above.
yeah.
All right. The strength of a magnetic field within a coil is dependent upon number of turns in the coil, current flowing through the coil, diameter of the coil,
Oh.
all the above.
Answer not available.
Okay.
When it is desirable to detect subsurface discontinuities, A, fluorescent particles in a wet suspension would be the best selection. Subsurface discontinuities. The visible dry particles used with AC would be the best selection. Visible particles in a wet suspension using DC current would be the best selection. The visible dry particles used with half-wave DC would be the best selection. Delta, the last one. Visible with half-wave DC.
Visible with halfway.
I don't like any of them.
Just remember. Okay, I'll remember it.
The halfway
Particle mobility can be increased by. You want to go, you can. Particle mobility can be increased by using either AC or half-wave DC for magnetization,
I don't think so.
using fluorescent particles in a wet suspension, using visible dry particles with prods, or both A and B.
C.
Yeah, they said the answer is D. I missed that one, which would be either AC or half-wave DC, which is true. AC or DC, right? So that's true. Using fluorescent particles in a wet suspension, they said is also true. I would have picked A. I did pick A and I got it wrong.
Yeah,
So
'cause couldn't the fluid actually kind of prevent it from-
yeah, that's
They
what.
said,
Yeah,
like,
that's-
they specifically
Yeah, they
said
said
that
it decreases mobility.
See,
Dry magnetic particles should be applied in such a way that they reach the surface under examination before magnetizing current is turned on, before magnetizing current is turned off, in a uniform cloud in large heavy clumps.
Uniform cloud.
Yeah, I missed it because I think B is also true before the magnetizing current is turned off. But,
Yeah.
all right, we done?
Are we?
Sure.
You're the teacher.
Because I got a lot of these questions.
Do you have another one of those keys, like liquid penetrant, where it has a bunch of questions like that again?
Which ones?
The one that you opened up the classroom first.
Oh, yeah, yeah.
I think Dan would do another one of those and get pissed off that
Sure. You can do that tomorrow.
Impossible.
I have that for magnetic particle, fluorescent penetrant, eddy current, and ultrasound.
Was that what we were doing?
Yeah.
Oh, yeah, where the answers just start breaking down in grade.
And when we start breaking down.
Not even 100 questions, just 90.